Welcome to this introduction to data virtuality. Data virtuality is the single source of access to data in your organization. So when building reports for regulatory purposes, but also for any other business purposes, you most likely will need to access data from all different sorts of data sources that are scattered across your organization. Now, the traditional approach how to do this is to copy all this data first to a central storage, which is usually referred to as the data warehouse, which you can then use to build your reports on. So this is a rather complex process because it involves copying data, knowing how your schemas will look like, and so on. So we believe that there is actually a more lightweight approach to do this. As you can see here in this picture, on the left side, you have the data sources. On the right side, you have the data consumers where you build your reports. And now data virtuality positions itself in the middle. And it will actually make the data available in real time directly from the data sources without having to copy them first. So this has two main advantages. The first one being that you now have just one single place in your organization where data is being accessed from. So this makes it ideal to implement your data governance processes, such as accountability, data access rules, or also tracing changes to the data model, because you know that everyone working with data will go through data virtuality because that's the place where all your data now resides in a logical way. And the second advantage is that it allows you also to quickly build reports with really minimum development effort, because you do not have this copying of the data, but rather the real-time access, which make you more flexible and more agile to build reports right away without spending too much time on first developing a complex data storage system. So let's start looking at the actual software. So we do have a desktop and a web interface. We'll start with the web interface here, which is the place you would go to first get an overview about what kind of data and reports there actually is available at all. And here on the left-hand side, we now see a list of different reports that have already been built. So we have an accredit report, a market risk report, and also an SFTR report here. As we have an accredit selected at the moment, we would then see here in the middle of the screen the different data sets that are included in this report. So for example, the first one here is accounting data, which then has a description to further explain what this data is about, and maybe also to include some additional important information that the person using this data should know. And also there is here the data owner. So this can be used for data governance purposes. So if you want to know, as someone working with the data, who is responsible for it, so that you can reach out to them in case there is any problem with the data, if there are any questions, or maybe also requests to change the data. Also, you can directly here download the data. So there are several icons here for some tools to directly consume the data, for Power BI, Tableau, for example, but also generic ones like downloading a CSV or Excel file, which you can just click add, and then the user will be able to download the raw data, open it in their preferred application, and then further consume and process the data. So this is a very easy way for non-technical users also to get an overview, what is available, have direct access to the data. And of course, this is also subject to permission settings. So in the background, we do have a very sophisticated security model, which specifically allows you configuring who actually has access to which data. So we will see here actually only those reports where we have been granted access to. So now that we have looked at the web interface, which is targeted more towards data consumers, let's also look at the desktop interface, which is used to connect your data sources and then build up your data model. So you can see here on the left-hand side a section for data sources. If we open this, then we will find that quite a few already set up here on this system. We will be taking, for the sake of this example now, a closer look at one example here, which is SHP HANA. And if we check the properties, then how to set up this connection is pretty straightforward. So you need the usual credentials like username, password, database, and the host of the data source. And then once you provide these information, Data Virtuality will look for all the metadata that is available. Now, if we open the data source here, we see 12 tables being present. So this is the metadata that has been read, the list of tables. And if we click on one of the tables, then we will also see the columns with the corresponding data types. Now, at this point, we didn't look at the data yet, but we can now start querying the data source. So if we double click here on this table, then we will get an SQL statement generated. So this is a standard query language for databases. And our central idea of how we do data integration is that we teach all data sources the same kind of query language. So usually different data sources have quite different aspects of how their query language is implemented, and they differ to some degree. And we add one additional layer on top, which is this SQL dialect that you see here, which is then shared across all the different data sources. And this way you can then also easily join different data sources. So in this case, this select statement here will get us the rows from that table, which is stored on the HANA system. And only when we execute the statement now, Data Virtuality will in the background fetch the data in real time from SHP HANA and will return us here the latest version of the data which we can see. Now, this whole concept, of course, gets interesting when you join data from multiple data sources. So querying one data source is pretty straightforward. But if we look at an example of how to join data sources, this leads us to another section here, which is called the virtual schemas. So this is the place where you can store your business logic, where you can store the logic how a certain regulatory report is built up, of what data sets it consists, what columns it has. You can prepare your data, you can clean your data, and so on. And we have one example here prepared, which is called demo_SHP. So this is a virtual schema which can be used to group certain data sets that belong together, for example, because they form one report. And if we take a look at that schema, then we will see a view here. So views can be used to encapsulate certain queries that you don't want to repeat over and over again manually, that you want to prepare once and then make it available as a part of your report. So here we have a join between the SHP HANA table that we just saw and a Microsoft SQL server. Now, what this shows is that you have just one single query language, which you can now use also across the border of a single data source. And this query here, which is kind of simple, it's joining via one common attribute that is present on both sides, and then sums up one attribute, and doing a group by can be stored as a view. And again, this view can be double clicked on, then we will get a select statement. And when we execute this, and now It's actually similar to what we just saw before with the HANA query, but now we are not talking to one data source, but actually we are talking to two different data sources. So data virtuality will get the partial data from each of the data sources, will merge it on its side in memory, and then return back to the client. So this way you can actually use a simple select SQL statement to retrieve data from different data sources without even being aware of the complexity and the technical details that are behind it, that you can just easily consume the data. Now, when we see the data, one of the interesting questions might be from the perspective of a data consumer to understand where this data is coming from. So maybe also for regulatory purposes, we need to be able to track where the data is coming from and document this, but also to maybe gain more trust by being able to understand where the data is coming from, what kind of modifications have been done to the data. And this is offered by the data lineage functionality. So you can just right click here on any of the values and then select show data lineage. And this will now give you a graphical representation of where this data is coming from. So if we read it from top to bottom, we see here that the order quantity, this is the column of that value we just clicked at, was generated by a grouping here, which got its data from a join, and then this join had another grouping, and finally the data came from that SQL Server table that we saw initially in the view definition. And also you can see the additional metadata here, like the owner, for example. So if you think there is something wrong with the data in one of these steps, you know who to reach out, and you can understand how the flow of the data is, what kind of modifications have been done, and get you better insights of why the data looks the way it looks like. So another feature that you can also do when talking about data governance is being able to understand what happened to your data model. So being able um, to audit changes to the data model. And for this, you can again right click here on that view and then select view history. So every change of the state of the system will actually be logged in the background so that you can trace it and understand who changed what. And here, for example, for this view, we now see three different entries. And if we scroll a bit to the right, then we see, for example, that it was created by the admin user at a certain timestamp, and then it was edited twice afterwards. And we also see here the definition at that point in time, so we can also easily roll back in case of any accidental changes, or we can review the changes to understand what was changed and maybe get a better understanding of also what the reason of the change was. So now that we have prepared our view, we might want to make this available to a broader audience as part of our report maybe that we build. And you can see, for example, the owner can be set here in the interface directly, the description. So those were two details we also saw before in the web interface. And now if you want to make this view here appear in the web interface, you can right click on it and then select to publish it to the Web Business Data Shop. And now this view will also be visible in the web interface, just similar to the NI credit report that we saw in the beginning, which is also represented here in the virtual schemas as one single schema. And then the different data sets that we saw before are represented here as individual views. So this way, this report has been modeled and then it has been made available to a broader audience in this web interface. Now, all the data access that we've seen so far has been in real time, directly getting the data from the data sources. There might be concerns why you don't always want to use live data, maybe because of load on the data source side, or maybe because the data is not always available, or you want to decouple your systems, or also maybe just want to make sure that performance will always be good on your reports. And there is actually the possibility to also improve this in data virtuality and to materialize the data. So store a cached copy in a relational database. And we can do this by right-clicking here and then choose to materialize the data. And if we do this, we can select a schedule. So let's say we want to do this at a certain interval here. So maybe once every hour, we want to refresh the data. And then every time this will be executed, the system will calculate the result set of that view and store it in what we call the analytical storage. So the analytical storage is a relational database. This can again be, for example, SAP HANA, an Oracle database, any sort of cloud relational storage on Azure or AWS, for example, also, of course, on-premise data sources. And every time the job here gets executed every 60 minutes, this cached version of the data will be refreshed. And as soon as we finish this here, the virtualization in the background will be triggered once. So the view will be executed, the result will be stored, and now you can see here the color has changed. It went from green to red, and also tells us here now that this data is materialized. So when we now query that same view again, the data will actually not come in real time from the data source anymore, but it will now come from that cached copy on the analytical storage. So this is actually a very powerful way how to improve the performance of your reports, also because it's transparent to the user. It doesn't change the way that users are accessing the data. And you can also disable it, for example, in the future if you think it's not necessary anymore. So there are also more advanced ways of how to define the refreshment of the data. So now in this example, we just took a complete copy that will always be replaced, but there are also more advanced methods, like for example, doing incremental updates to make sure that you have the most ideal performance here on this side. So this is a quick example and overview of how you can build your own reports in data virtuality. There are, of course, a lot of more details to consider here, but I hope this gave you a good first overview. Thank you for watching.